All right, guys, we're going to start off. I know for the three of you that were watching, here were the review questions that we went over and stopped with last time. So, you know, the atmosphere and all. We're going to give this a shot. Okay? Did we go through two? Let's see. How many of these did we go through? We're working on it. You know, tech stuff. Okay. Here's where we left off. My gosh, I have to hit the arrow button. There should be directions on this. Okay? Ooh, there's the answer again in case you didn't have it the first time. All right. Thank goodness. Forget air quality. All right. We're going to go through air quality because this is one of those things that I talked about with the pollution. How we're going to have to pay attention. Remember, just a quick review of the atmospheric things. Stratosphere, troposphere. Stratosphere, troposphere. Ozone in the stratosphere, good. Ozone in the troposphere, bad. We're going to be hitting on that, right? Please pay attention. So air pollutants are, as you can see, gas and particulate matter added to the atmosphere that can affect climate or harm people and others living or other living things. You know, we're only concerned about us, so that's basically what we're going to focus on because, you know, they're not going to ask you what's happening to the fish with air pollution, even though we can turn that into water pollution. Oh, right, we did a chapter on that. Yeah, go back and look at that. Okay? So air pollution is the release of air pollutants. And we can have two types. Remember, you can have point source, anything you can point at and look at, or you can have non-point, where you're not quite sure where the pollution is coming from. So here we have, in recent decades, public policy and improved technology has helped reduce most types of outdoor air pollution. Guess what? If it's reduced outdoor, what must we be concerned with? Indoor air pollution. I know. You're looking forward to seeing what that's all about. All right, so here's obviously a fire in California would be outdoor, in case you were confused. Okay, we have natural processes. We know that volcanoes go off. We know that fires are supposed to happen naturally. However, is climate change helping with that? Probably just a little bit. Okay. Fires occur naturally. We know the Everglades burn all the time. We see it. It's supposed to. Otherwise, things don't work out. We don't do anything about it here unless, you know, it starts getting close to a house. Then we get all upset. Fires occur naturally but are worsened by human encroachment into fire-prone ecosystems. You know, it's pretty where all those trees and things are. So we like to build our houses there. And the suppression of fires in areas where it's part of the natural ecology. You can start looking at where sometimes the Everglades, we have prescribed burns. They go through that. I know they do that in other counties. They let you know. Mount St. Helens, none of you are alive, but it was bad. It was like the entire top went boom, and then all of a sudden it was there. It wasn't. All these things, see how you can see those? Particulates, all right? Volcanic eruptions release particulate matter and sulfur dioxide. Sulfur dioxide, what happens? We learned this in the other chapter. What happens when you mix that with water? Sulfuric acid. No, that sucks. What happens with sulfuric acid? We know it ruins stuff in the water, and those forests and things, they don't like that. Acid, what? Precipitation. All right, so short-term effects. Please make sure this could be a good essay question, your short-term effect compared to your long-term effect. Short-term effects, grounding planes, because that particulate matter in there, it has lava stuff. No good. Okay, damaging car engines, causing respiratory illnesses. Yeah, if you suck that into your lungs, you can see how that wouldn't go over well. Long-term effects such as global cooling. Let's go back and see what happened. There was a mini ice age at some point, and they said that there was a lot of volcanic activity around that. That's history. Let's go back to that at a different time. Can occur if sulfur dioxide reacts with water and oxygen to form aerosols that block sunlight in the stratosphere. Maybe even that's like one of those things that they've talked about. Okay, if it shakes, it's because the cat is in the way. You think I got distracted by you guys in class. Now I got animals going off in the background. I know. You know I have that little ADD like a squirrel comes around. So when we get stuff all the way from the deserts in Africa coming over, and that causes pollution in our air. It also brings in nutrients over into the tropical rainforests that we have over in Brazil. They get some of their sediment there from Africa. I know. It's amazing how that entire atmosphere thing is all connected. Wow. Okay? This is worsened by unsustainable farming. Yeah, Because now look what happens. Farming, we know what happens, too much of it. Desertification. Uh-oh. Tilling, we bring up stuff. It goes up into the atmosphere, floats over. Grazing practices that strip vegetation from the soil, as well as, oh look, desertification. You know I should read these slides in advance. I don't. I should. Okay. Oops, did we miss two? No, we did not. Okay. So we create outdoor air pollution besides volcanoes, besides dust, besides fire. Oh, there are other things that, guess what, we do. I know, it's a surprise. So pollutants released directly from the source are called primary pollutants. Please keep this in mind because we're going to go over different things. Remember, I talked about ozone in the troposphere, bad, ozone in the stratosphere, good. That's going to have differences between primary and secondary pollutants. So ash from a volcano, sulfuric dioxide from a power plant, carbon monoxide from a car are all examples of primary pollutants. Those that react with each other or components of the atmosphere form secondary. You are going to need to know secondary pollutants. They can ask you, it's been an FRQ twice now, giving an example of secondary pollutants. So please pay attention. Ozone, which is formed from pollutants in urban smog, is an example. Secondary pollutant. It's like I know some of this stuff. You know, this is not as much fun as watching some of you pretend to be paying attention. My cat is, my dog woke up, but it's not the same. So, residence time is the amount of time a pollutant spends in the atmosphere before settling to the ground. Each one of these have variable amounts. Do you need to remember these different chemicals? You should know some of them. You should know stuff like your sulfur dioxide. You should know carbon monoxide. We went through chlorofluorocarbons, things like that. Oh no, we didn't. We're gonna be how long they take to be released into the atmosphere and how they stay there forever and why we have holes in the ozone and things like that. So short residence time result in more localized impact over shorter periods. Longer residence times cause long-term, regional, or global effects. Once again, do you have to have this memorized? No, but are they giving you a graph? What do we do with graphs? We have to interpret graphs. Do we need to know anything about them? Yeah, how to read them. So if by now you can't read a graph, number one, be embarrassed. Number two, ask someone else. Except if you're on a test. Don't ask anyone else. Okay. So the Clean Air Act, I know. We'll pretend like, you know, that's still being enforced and there's an EPA and someone's overlooking. All right, let's try to work with that one. Is a U.S. law passed in 1963, amended in 70, 90. They keep tweaking it. Good, that's my cat pushing stuff off because that's what cats do. Sorry about that. You know, Chester, he's special. You know, he has friends, his own Instagram if you wanted to be following that. That funds pollution, controls research, sets standards for air quality, and encourages emission standards for automobiles and other point sources. We talked about automobile pollution before. We talked about how Florida used to have auto emissions. Now we don't because we realized the people we were checking, the cars we were checking, weren't relevant because they weren't the ones that were polluting. Anyway, states are required to monitor emissions for air quality and develop, implement, and enforce their own regulations to comply with the law. Enforce their own regulations. So you can imagine certain states have more enforcement and are more concerned than others. Now my cat's playing soccer, just in case you can't hear that. Oh look, pie chart. Ooh, everyone can read that one. State and local agencies monitor and report to the EPA. Do they? What does the EPA do anymore? Oh, we know that's a whole other discussion. Debate people, you bring that up. Carbon monoxide is a colorless, odorless gas produced by the incomplete combustion of fuel. Carbon monoxide is the reason why, if you guys have a garage, go look. I'm not kidding. Go look. There is a step up or a ramp from your garage inside your house. Why? Carbon monoxide, it sinks. I know, so that way it stays a little bit lower if you have problems with your car. So, vehicles and engines are the biggest source. Carbon monoxide binds to hemoglobin in the red blood cells, preventing it from binding to and transporting oxygen. And you all have passed bio and the bio EOC, I'm just really hoping. And you should know that oxygen, very important to us. So you do not want your oxygen replaced by carbon monoxide. Because, you know, that aerobic respiration and everything, keep that in mind. So nitrogen oxides. See, they're giving you NOx because there's a whole bunch of them that are out there. And As you know, because we talked about it with water, okay, we can go through and we can get nitric acid. Guess what? Acid. That can be part of some type of acid precipitation. So there are families of compounds that include nitric oxide, nitrogen dioxide, okay, produced when atmospheric nitrogen and oxygen combine during combustion in engines. Looks like combustion in engine does not do us any good, except for, you know, cars. I mean, we're fans of electricity and cars and stuff. But maybe there are other solutions. I'm just saying there might be another one. I'm just, you know. So they contribute to smog, acid deposition, and ozone depletion. Stratosphere, not troposphere ozone, because stratospheric ozone is the one that's important. So volatile organic compounds, you see this, VOCs. Go look and paint, okay, varnish, anything that, like, if you're painting your house, you can go and you can spend the extra at Home Depot for low VOCs or no VOCs. That's not going to give you the funky paint smell. There you go. Volatile organic compounds are carbon-containing chemicals emitted by vehicle engines and solvents. It gives you some examples. Methane, propane, octane. Okay. Do you need to know examples? No. Do you need to know what volatile organic compounds are? Yes. So they react to produce secondary pollutants, such as smog. Once again, a primary pollutant and a secondary pollutant. Please make sure you can go through and distinguish one from the other. And if you had to pick it out of multiple choice, they're not going to ask you to name a primary pollutant. They might ask you to go through the process of, this is the primary pollutant. How did you get a secondary pollutant? Okay, then we have particulate matter, floaty things in the air. No good for your respiratory system because your lungs don't like to have chunks of things in them. Okay, it's composed of solid or liquid particles small enough to be suspended in the air. Can be a primary pollutant, dust, soot. Soot could be coming from burning of an industrialized, whatever it may be, okay? Or secondary pollutants, sulfates and nitrates. So for example, if we were, say, aerosol spraying fertilizers, not pesticides. We still got that wrong on the last one. I'm just saying. So if we were aerosol spraying them, then they could be, you know, airborne. So particulate matter is classified by size. No one's going to ask you the size. Trust me, they're not going to ask you the size. So then we have lead. Lead is a heavy metal, okay, that can enter the atmosphere as a particulate pollutant as a result of vehicles burning leaded gasoline, which we don't have since the 70s, or metal smelting, or if you were in the Victorian era and you were putting all that white makeup on, that was made of lead. That's why they kind of, you know, in that, Elizabethan era? You know, I don't know European history. People work with me here. When they were doing all that and they were getting their face all nice and white and they were all going slightly off the edge there, yeah, this is why. So lead is a toxin that can accumulate in the body and cause a nervous system malfunction. Lead is also something where they're trying to get that out of bullets and hunting because of, guess what we have? Bioaccumulation. We can have that in our raptors. They have it out west in animals when they shoot them and they leave them there and they have lead pellets in them. And then you have your vultures and other birds of prey that come in and eat that and they end up with, you know, bioaccumulation of lead in them. Yeah, no good. Oh, the dog woke up. He was concerned about that. So we have reduced this. We do have the ability. If we change it, we can fix it. And if you go and look at pictures prior to 1970, go and look at Pittsburgh, go and look at LA, go and look at Mexico City. Before we had all these regulations, it was like brown or orange and stuff like that, just weird stuff. And you could tell, you don't want to, you know, like pictures sometimes that they have of China nowadays in the cities, obviously not in the country. The emissions of the 6 monitored pollutants have reduced dramatically. Once again, yay graph, okay? We like a graph. It's showing you how much. Could it ask you about the percent change? Yes. Could it ask you, this is what happened? What do you think caused the decline? Yes. You better know because of what? The Clean Air Act. It's one of those acts that you have to name. There go. Ooh, I hope I'm still in the picture and it's still going. Sorry about the shaky. Can't control a cat. Okay? So here we have what's called a scrubber, all right? Technologies such as baghouse filters, electrostatic precipitors, and scrubbers. These physically take and remove airborne pollutants from smokestacks. So you have some type of industrial combustion that's going on, and even just think of a pretty fire. If you don't have a gas grill, if you have a charcoal grill, the smoke that's going on in the air, the reason why it has a color is because of particulates that are in it. So if you're doing this on a huge industrialized basis, you don't want all of that going into the air. So the good news is we have scrubbers. The bad news is we still then have all of this sedimentation here that we have to get rid of, and probably toxic. What are we doing with it? Where are we dumping it? Who's regulating what we're dumping it? Where we're dumping it? Oh my goodness, I'm gonna have to beat the cat. Okay, I might have to call in for reinforcements. Okay, so catalytic converters in our cars from the 1970s. I don't know cars. I was gonna make it a year up, but I don't know. No one's gonna look. All right, contain metals that react with hydrocarbons, carbon dioxide, those nitrogen oxides, whatever they may be in vehicle exhaust, and convert them to carbon dioxide, water vapor, and nitrogen gas. We also phased out our leaded gasoline. You can't buy leaded gasoline anymore, just truly because of this. So the EPA estimated that between 1970 and 1990, look at how much, okay? Clean air regulation technologies advanced pollution controls 200,000 American lives. So that's everyone across the board, not just, people in poor areas or people in, in good area, everyone. It was a good deal because, someone enforced it. There were probably, taxes that paid for that. I know, it's just awful going off the edge on that one there. There's a picture. Here's the chemical reaction. Do you need to know that? No. Okay? So, our air quality has improved. Has it been reverted? Yes, but our industry is industry. That was poor in the grammar sense, sorry. So is industry going to go back to 1970 standards? No. What are they going to do? Change all their factories? No, they're not going to do that. So monitor the concern of 6 criteria pollutants that are known to pose substantial risk to human health. These are the ones that they most closely monitor in theory. It has an ambient air quality standard which sets the maximum allowable concentration. 4 of them. You should know these. So if you'd like to pause the video, because look, now if I'm on YouTube, you can pause. I know you don't want to because, it's fabulous as we're going on. Okay, carbon monoxide, sulfur dioxide, particulate matter, and lead in the air. Nothing we can do about people licking it off the walls, okay? So here we are, nitrogen dioxide, and you need to know these colors. I know it seems weird, but if it has a color or a funky smell or something like that, that can be something that can be identifiable on a multiple choice question. So nitrogen dioxide is a highly reactive reddish brown foul smelling gas. So you need to know if they said that there's a reddish brown foul smelling gas, you would have to pick out nitrogen dioxide. They might give you other things, so you need to know that's associated with that. Often I don't point these, I try to point out things that I know are going to be asked. So tropospheric ozone, ozone in the troposphere, bad. Okay, also called ground level, is a secondary pollutant. You must know that this is a secondary pollutant created by, look at this, the nitrogen oxides and VOCs and sunlight. It's hugely important to know that sunlight is involved in this, okay, because there have been questions in the past about traffic going in the morning and when would be the highest amount of ozone level and what would be the cause of this, and you would need to know that ozone is produced as a secondary pollutant because the cars were going in the morning. They were releasing this, and then over the course of the day, the longest amount of sunlight, by the end of the day, the most amount of ozone was being produced. Not because there was more traffic, but because it took that sunlight to make that secondary pollutant. Hugely important. Right there. I'm telling you now. Right there. Okay? Ozone is an unstable molecule that can injure living tissues and cause respiratory problems. It's bad in the troposphere. How many times have I said this? Like 20 just right now? Okay, good in the stratosphere because it allowed us to evolve out of the water, right? Protects us from UV radiation. Don't get that wrong. So, more than 4,000 monitoring stations take hourly or daily air samples. And we're going to ask you that? No, I just thought I'd throw it in there because there's the line. Ooh, graph. Nice. Look at all the pretty colors. Okay. Notice downward. Why? Standards regulated by the EPA. We kind of dig the EPA. I do. You may have different opinions, but don't voice your opinion. Just go with what I'm saying. All right? We're very happy to have seen all of this go down. Most recent national standard. Look at that. We can read all that. Don't need to know it off the top of your head. Ooh, another picture. Oh, okay. Look, we're pretty good in Miami because, you know, we don't do anything. We don't have anything. We don't produce anything, all right? Here's where we don't want to be. Okay, but look at how much it's gone down. Look at this. From 85. Okay, you're like, I wasn't around until the 2000s. I know, I get that. But, you know, just work with me here. Okay? That's a huge amount that's gone down. Also in Philly. Look at LA. LA still kind of sucks, but remember, LA has that mountain. So air has a problem. It gets stuck. It has a lot of inversions that happen there. Remember that one? So air kind of gets stuck because of the mountain range and it's being pushed in all those cars. Have you seen? Okay. You've seen pictures of LA. So all those cars are going in. The winds are coming this direction and the winds don't make it up over the mountains. So the pollution gets stuck. That's a good graph. Okay. So what's a toxic air pollutant? I bet you could guess, but they're giving you the definition. Substances known to cause cancer, reproductive defects, or neurological developments, immune system, or respiratory problems. These include substances such as mercury from coal-burning power plants. There is no clean coal. If there is clean coal, that's because they cleaned it and have done stuff with it. It didn't come out of the ground clean. I'm just saying, okay? VOCs from gasoline and methylene chloride found in paint stripper. Okay. Probably not a heck of a lot of that, I'm just saying, compared to everything else. But they're just giving you the heads up. So rural areas, people may be exposed from pollution from sources such as pesticides from farmers. Please, even on your last FRQ, people still pesticides, fertilizers. Why can't we get this right? I don't know why we can't get this right. Okay, industrial pollutants that drift from distant cities. Methane, huge. We've talked about methane with cows. We've talked about the methane increased, especially as countries become more developed. They get more money, they want more cow. Okay? So, hydrogen sulfide, ammonia from animal waste in large feedlots. Ammonia is going to come from the urine. In case you have not ever smelled cow pee, once you smell it, you know what it is. Okay? Fumes from natural gas extraction sites. So air quality is worsening in many, industrializing. So as countries are moving through, remember we need to know those stages of industrialization. As they're moving from underdeveloped to developed, they go through those. As they're industrializing, the result of proliferation of factories, power plants, automobiles, and the use of wood, charcoal, and coal for cooking and home heating. So how they're generating electricity, the fact that some of these countries are still, cooking by burning wood. We're not, okay, but, you get how that works. Many power plants and factories use outdated, heavily polluted technology because it's cheaper and quicker to build. It's outdated, so all of the stuff is easier to get. That's what's happening in places like, for example, India, okay? They're growing at nobody's business with the amount of people. They're growing more and more rapidly, so what's happening? The cheapest way to get electricity is through coal. China's doing all. They're growing at nobody's business, but they're heavily invested in, renewables. Not that they don't have coal, because coal is still the cheapest. Okay? Oh, look, here's an example. Phew. China's capital city, 2013. Okay, not so bad. 7 years. I mean, come on for a textbook. Let's work with that here. Okay, it became severe that flights were canceled and people wore face masks to breathe. I mean, you can barely see that building. I was going to call it a pagoda, but I think that's in Japan. So I apologize. The air quality index measurements were off the chair. Nope, that's a scale. Okay. So look at that, and if you look at pictures way back, you could see that in the Industrial Revolution in Pittsburgh. You could see that in California in the 70s. I mean, but now we know, bad. Okay. And here, yuck. Okay, you don't want to sniff that in. I mean, your lungs do the, if you were just walking through and this was your only day, you'd probably like be, coughing up a fur ball or something like that, but you'd probably be able to recover. But if you're stuck in that and that's what your daily life is like, probably not going to go well. So, worsens in city in India and other Asian metropolises. That no one's here to help me pronounce that, okay? So, according to WHO, 13 of the 20 most polluted cities on the earth are in India. Once again, that is expanding even more rapidly than China. China has, some control. India is more of a democracy, so rules aren't rolled out like they are in China. Okay? Smog poses health risks. Thank goodness they gave you that slide, because otherwise you would not have known. Okay? It's a general term for mixing of air pollutants that can accumulate as a result of fossil fuel combustion, especially over areas with heavily automobile traffic. It's just heavy. There's no LY in there. Sorry about that. Okay? So, if they have a specific type, it can be called industrial smog. Guess what that's coming from? Oh, factories. I know. You were wondering. Thank goodness I filled you in on that. Okay? Here's a good picture. Coal, oil, soot, particulates. No good to suck that in. Look at that. Sulfur dioxide goes up in the air. What happens? It mixes with water vapor and oxygen. No one's going to ask you. You chemistry people, you might get that as a, like it might be part of an FRQ and you would get the extra 1 point for knowing that chemistry, but otherwise, no one's going to ask you to do the chemical equation on that one. See, ooh, yee, that's midday. Look at that picture, okay? Look at that picture. Midday in 1948, before regulation. We don't want that. No one wants that again. I mean, look at that picture. So, America's worst industrial smog event occurred in Pennsylvania in 48, okay? It's in, once again, a valley. Like we talked about with LA being stuck there with the mountains. We talked about Mexico City being in that cauldron. This is also in a valley that trapped it. London had a similar killer smog in the 50s. Holy crap, that's a lot of people. In London, wow. And here's photochemical smog, okay? Photochemical smog. You must know photochemical smog, okay? You must know photochemical smog, okay? Forms when sunlight drives chemical reactions between primary pollutants and atmospheric compounds, producing a mixture of over 100 different chemicals. Ozone is the most abundant. Ozone. Troposphere, bad. And this is how we get it, okay, as a secondary pollutant, not as a primary. It is as a photochemical smog. You must know it. You must know it as a multiple choice question, and you would have to know it probably as FRQs. It's been on at least twice since like the 90s as an FRQ. Windless, warm, sunny days. Ideal conditions for photochemical smog. All right? You look at that in your own time and enjoy the picture. But you have to know that it comes from cars. There has to be solar radiation. And the longer that solar radiation in cars are out, the more you're going to get. Okay? So, can we reduce smog? Yeah, okay. Many steps, many. California's already done that because, you know, California's ahead of the whole thing on this. Restrictions on emissions from power plants, oil refineries, other factories, vehicle inspections. They have the most rebates on alternative vehicles to combustion engines. I told you about my friend's, hydrogen car, the electric grid that they have out there, the electric charging station grid, the hydrogen charging that they have out there is second to none. Well, none with the hydrogen because they don't have it anywhere else. Okay? Ooh, another graph. We love them. Okay? Ozone levels are still in excess of EPA standards, even now. Okay? They've decreased since the 80s, but there are more people. More people traveling, more people on the road. You go to LA anytime, it's like, people don't have jobs. Well, apparently they have jobs that cause them to drive really slowly on the highways. Okay? In 2007, Supreme Court ruled that the EPA had legal authority under the Clean Air Act to regulate carbon dioxide and greenhouse gas emissions. You can go back and look. Why not? Why wouldn't you go back and look? There were a couple of those senators, congressmen, I don't know who they are, who went back and said, well, how can we make that, a greenhouse gas, and how can we regulate that? We're going to tell people to stop breathing? Yes, you idiot. Bring your snowball back in and tell me the difference between climate and weather. It's probably the same dude. I don't know. I'm a little bitter about that. So in 2011, the EPA introduced carbon emissions standards for cars and light trucks. We still, for heavy trucks, the ones that give off most of the stuff, we're working on that. Ooh, just saw a thing the other night. Oh my God, on the driverless cars. So cool. Now we need them on driverless trucks. Holy cow. That was so cool. I digress. I'm trying to pay attention because my dog is now limping around and he's going to pee on the carpet any second. But I'm going to get over that. Okay? Standards for power plants followed. Okay? Look, now we're at 2015. The EPA launched the Clean Power Plan, which gave states options for reducing carbon emissions. Cap and trade programs. We're going to go over cap and trade programs. You need to know about cap and trade. They're good. They're not the greatest. They're good. They're not the greatest. It's better than nothing, not as good as it could be. Okay? So here are our review questions. Sulfur dioxide. You can read it. You can pause it on your own. Look at that. You got that capability. There's the answer. Which criteria pollutant? Can't say it enough. How many times have I said it? Troposphere, ozone, bad. If anyone gets that wrong, we should be able to point at you. I think I should be able, if we ever have a test and we ever meet again, if I ever have a test and someone gets that wrong, I think we should make them stand, point, and laugh. Everyone thumbs up if you like that idea on the video, all right? So, ozone depletion and recovery. Ozone is highly beneficial gas in the stratosphere. Okay, stratosphere. Remember, I talked about the whole thing. UV light, bad, takes apart your DNA, sucks. But once we had ozone, not as much UV radiation comes through. In the 80s, we figured out that human-made airborne chemicals called ozone-depleting substances were causing that big, huge hole that we had in the ozone back then. It's repairing itself, but it was bad, man. All those poor people in Patagonia were just like freaking getting skin cancer like nobody's business because that's where the hole was. Primary ozone-depleting substances are halocarbons. Okay, synthetic compounds derived from hydrocarbons where hydrogen atoms are replaced by atoms of chlorine, fluorine, and bromine. You chemistry people, you know where those are, right? Okay. One specific class, chlorofluorocarbons, were produced in the 70s for use in refrigerators, fire extinguishers, propellants for spray cans, and cleaners for electronics. Sorry. I did. Pookie. Sorry. Okay. He'll contribute now. So here's where we have them. They were in your refrigerants. They were in your air conditioner. Oh my God. I can't imagine how much hairspray from the 1980s contributed to this. I know it was about big. It was bad. Okay, number one, the hairstyle was bad. Number two, now that we know the amount of stuff that was being released into the atmosphere, holy crap, I feel bad about all those bad hairstyles. The bad hairstyles and the hairspray. Okay, so in the stratosphere, chlorofluorocarbons are broken down by UV radiation to chlorine and carbon, split many ozone molecules. So, the ozone, here we have down at the South Pole, Antarctica, okay? You can see, I mean, they have so many satellite pictures of it. Opening, closing, it's really creepy, okay? 85 researchers detected an area of thinned ozone called the ozone hole, okay? Every spring over the Antarctic. High-altitude polar stratospheric clouds containing nitric acid were breaking down chlorofluorocarbons into chlorine, which was then being released in the spring when the sun broke up the clouds. So it was happening every spring, and it had to do with the light actually finally coming in and hitting down there, because we all know about the tilt of the earth. We know about how, sorry, now I got distracted by a bunny, okay? We all know how the different angles down at, for part of the year, Antarctic, no sunlight, and all this stuff gets together, and then the sunlight starts coming and starts breaking it all apart. Scientists were concerned that the elevated UV levels could promote skin cancer and damage plant life. No kidding, like things that have DNA and all. I know. They were concerned. Yeah, they should have been. Okay, so with this, like I told you on the last one, there's certain things you need to know. You need to know the Montreal Protocol. You need to know the Montreal Protocol. Thank you for those of you who remember CITES and the Endangered Species Act for the last one, but you also need to know the Montreal Protocol. It was signed in '87. Countries agreed to cut chlorofluorocarbon, okay? And they really did a huge job, and you can actually see satellite pictures of the ozone repairing itself, okay? So here it's showing you, I don't know what that dent was, millions. The Montreal Protocol is now considered to be a model for solving global environmental problems. Everyone jumped on board. No one was in disagreement that we were losing, that there was a freaking hole in the ozone. Everyone agreed. It wasn't like, it was fake news or anything like that. They could see satellite imagery. Gee, hole, wasn't there before. Okay? So then we have acid deposition, the deposition of acid or acid-forming pollutants onto the Earth's surface, which you can imagine what that does to water. We already know what that would do if you're a fish and you can only live in so much of a pH. Say you could live in a pH of 6, okay? And then you get acid deposition in the form of rain, and now your water is 4. You can't survive that, okay? Like with ozone depletion, this is a global problem. Tragedy of the commons. Maybe you could use that in an essay question also. I'm just saying. Okay? Acid deposition, acid rain, acid precipitation, whenever wet stuff comes down. Or you can even have acid fog, which is just freaky, but it can happen. Okay? It's one form of atmospheric deposition, which occurs when any solid or liquid material from the atmosphere is dropped onto the Earth. Lovely picture. There it happens. Okay? Burning fossil fuels, releasing sulfur dioxide. Look, it's like the same ones over and over again. Sulfur dioxide, nitrogen oxides, and they all react with oxygen and water and make acids. And no one wants those things to fall down on them. No one. No one. Okay? Enjoy. Okay? And look at this. You can see melty stuff. When it melts monuments, that's a little upsetting and a little freaky. Okay? And look, this Clean Air Act, it came back in. Established the acid rain program to fight acid deposition. It set up an emissions trading program for sulfur dioxide, allocating permits for sulfur dioxide pollution and allowing emitters to buy, sell, or trade these allowances. So they got money for reducing. Ta-da! Okay, cap and trade program. This is how much you're allowed. I'm going to put the dog down. I don't know if I'm going to be successful because sometimes he's a whiner. I can't put him, I have to put him on the carpet. Oh, he's hot. Okay, so here what happens with cap and trade is you're allowed this much, okay? This is your cap. What happens if this little company down here only uses this much? Well, you can trade their pollution that they're not using and you can give them money. That's where the cap and trade thing came in. It'd be good if there was just a cap and no trade, but it's industry and someone's losing money and it's very upsetting to someone. So here we have precipitation in 1990. Precipitation, pH precipitation, okay? One that it was not good. So you can see we were able to fix it. Most things in nature, if we get out of the way, nature fixes itself. It might not be as fast as we would like because, we've only been around for a couple 100,000 years and, the planet a couple billion. So our time frame may be different. So indoor air quality is called indoor air pollution. Convenient, okay? Many earlier steps taken to reduce energy consumption, such as limiting ventilation, installing windows that do not open, worsen indoor air pollution. So now you've made everything energy efficient, but now you're not having air circulation. So then you have indoor air quality problems. Every carpet you bring into your house, every new piece of furniture, they often release VOCs if they have that funky new carpet smell or that funky some smell going on like there. That's indoor air pollution. Okay, this is a different type of indoor air pollution, okay? Burning fuel inside, bad, but if that's your only option, you have to eat. So in the developing world, wood, charcoal, animal dung, which is poop, in case you were unaware, okay? Or crop waste may be burned inside a home. And then obviously you're getting particulates in there. So smoking cigarettes, no good. We already know that. Secondhand smoke, bad. Okay? More asthma, more cancer, more lung disease, emphysema, allergies. It's just a cluster boo-boo going down there. And then you have radon. We've talked about radon before. Okay? Radon is coming up. And it's a radioactive gas. Okay? And it causes lung cancer. We are not on the type of rock here in Florida that produces radon. There was a big freak out a couple of years ago and everyone's like, oh my goodness, my granite countertops. Hey, now everyone's doing quartz. It's not the same. But no, the amount of granite that you have in your house doesn't matter. But there are radon detectors. Okay? Presence of radon, look at Florida. Low. Don't lose sleep over it. But do know that it does happen. Okay? It is a colorless, odorless gas, can only be detected by a special kit. Okay? And associate that with lung cancer. Please don't forget that. Okay? Many VOCs pollute indoor air quality. Like I already said, plastics. If you can smell it and it was not produced naturally, it's probably a volatile organic compound. Laser printers, fax machines, I mean, you smell, it's like, So chronic, okay, mostly respiratory. So here's showing you a whole bunch of different ways in your nice tight house that you got going on there. And living organisms can pollute, obviously. The most widespread source of indoor air pollution may be living things. Dust mites, hey, we're not controlling that too much. Fungi, mold, mildew spores can cause allergies. We already know that there's sick building syndrome. Ours, we know we have a couple of hallways, not so good about that. You know, it gets cold, it gets hot, it gets cold, it gets hot. Oh, the roof leaks, no kidding. What do you think's happening with that mold? It'll just be a surprise later on. Okay? In the developing world, multiple measures can improve indoor air quality. Don't burn inside, cook outdoors. Okay? Use less polluting, install hoods, chimneys. Developed countries can reduce their exposure by not smoking, testing for radon, mold, minimizing exposure to source VOCs. So if you're going to paint or if you're going to paint, buy low or no VOCs. Look for that labeling. Remember, the more you know, the better choices that you can make. Okay? So a state is looking to reduce air. What is it? What is it? What is it? Ta-da! Okay? Ooh, fill in the blanks. Montreal Protocol. You must know Montreal Protocol. I'm just saying. And it's one of those that you need to be able to pull up. Like you need to be able to pull up the endangered species. You need to be able to pull up CITES. You need to be able to pull up the Montreal Protocol. Okay? Most significant form of indoor air pollution? Particulates. Ta-da! Thanks for joining. I'm going to upload it. We'll see if it works. Because goodness knows what's happening.